everybody, happy Monday. Thank you very much for joining me today. So, normally on these Monday slots, I'm usually having a listen, so if you've got any questions you want me to have a play with, anything to do with graphs, so things we've done in the past, we've done Bloom perspective, we've looked at browser guides, looked at GraphQL and that kind of thing. So usually if you've got any questions, let me know and we can explore these on the Mondays. But I thought we'd do something a bit different this week. And what we're going to do is we're going to have a look at This Week in Neo4j, so the current issue for this week. And I'm going to pick an article. So I've already picked an article. That's Game of Thrones by Nathan Smith. And I thought what would be fun is let's go through the article. Let's have a look at the queries in there. Let's have a look at what it's trying to do. And it's something that we can do together. So if it's something you would like to do too, and we'll step through the article, there's some instructions there. So you can do this in Sandbox if you've got Sandbox handy. I'm going to be doing it in Neo4j desktop, so the choice is yours. But I thought let's have a look at this, and please do, so if you've got any questions or things, do let me know, ping them in the chat, and let's see how we get on with this. So this is something new and exciting, and probably heads up to give you as well, that on the we're at the 15th, aren't we? So the 29th of June, we're going to be doing something really special. So do watch this space. So 2 weeks today, do watch this space. We're going to do something cool. And right, let's get going. So if I bring over This Week in Neo4j. So for those of you who have not come across This Week in Neo4j, it's a weekly article which my colleague Mark Needham puts together, and this will be all the various bits and pieces that are coming along. So this is really great to see the fantastic things that the members of our community are doing. So our community members will be talking about projects they're working on, how they're using graphs, if they've built any amazing plugins or graph ups or that kind of thing. You know, we collate all of this information, and Mark collates all of this information, and he produces this really great sort of quick read curation of all the content, the new content that's out. And it's really great. And let's just have a quick look. So you've got two ways you can access the blog post. So you can either sort of go to the Neo4j blog page. So Alex has just posted a link in the stream chat. And the other option you can do is you can subscribe to the newsletter. So I believe, let me just check if we've got a link on here. So if you go to, I believe it's community.neo4j.com/twin4j. So we'll get the link in there, we'll check that. You can subscribe, and then what happens there is every week you'll get it in your inbox. So like that, you don't have to check the blog page. You'll get that delivered to you on a weekly basis. So it's really great content. You'll have videos in here and so forth. So normally the setup for these is we'll have a featured community member. So this week it's Sebastian Daschner, who's in there, and we'll also highlight anything. So for example, any sort of key videos that come along, some blog posts, for example, Tomasz Bratanic has written one recently, new apps, so this kind of thing. And sort of the vast majority of the content you get here is from the community. And we'll also, if there's any updates coming up, so for example, the Go driver 1.8, which is now pure Go, so there's no Seabolt is released. So any kind of product updates or new tools or things like that, we'll also report. So it's a really great way to have a look. And as you can see, as an update, it's a couple of minutes you can read through. And if you see something that catches your eye, then you can delve in further. And something I was quite keen to have a look at today is let's have a look at this article by Nathan Smith, which let's head over to the blog post and look through it. And so what Nathan has been doing recently, he was community member of the week last week as well, so I'll just quickly plug that. And what he's been doing, he's been reading the book Network Crowds and Markets, and he's been working through the various examples in that book, and he's been blogging about them, and he's been having a go at building those in Neo4j. So it's a really, really good series. And last week he put together this one, which is Game of Phones. And this article is all about trying to understand what drives the spread of technology. So why do certain technologies do well. So what, somebody picks up something new, this new innovation, and it does well, and why do others perhaps not have such much of a spread? And in this article, Nathan talks about, well, actually, a lot of the driver behind the spread of innovation, or the spread of pickup of innovation, is going to be based on the influence within a network. So how a network sort of, somebody in a network sees that sort of technological innovation, and what the influence is within their network. And it's quite interesting because he talks about sort of innovation in this example here, but it's also applicable to other things as well. And as sort of Nathan points out, and it's something that I've sort of noticed as well, is influence comes in many different ways and forms. And as Nathan flags as an example here, if we think about sort of coronavirus and how people are responding to it, and you sort of think about, there's many things around that. So one mentioned here are masks. So whereas before perhaps we wouldn't necessarily think about wearing masks, certainly in Western culture, it's not you don't traditionally wear a mask. Whereas now our attitudes are changing to that, and that's more acceptable, and you have this sort of influence pushing through where people are more likely to be wearing masks, irrespective of the messaging coming from government. Another example as well, perhaps looking at social distancing, certainly I notice now that people are naturally doing that. So when I walk down the street, that we all sort of naturally keep our distance away from each other. So you can see these sort of influences going on, and how we sort of adapt and start to build in these various things. So it's really interesting, and Nathan's written about it in this blog post. So I thought what would be interesting is to have a look through this, and what we're going to do is we're going to build through the examples that Nathan's got here with the code. And what I'll do as well is I'll talk through some of the code too, so we can explain what's going on. So we can do this together, and this is a great opportunity for those of you to go through along. And again, if you've got any questions about the queries, now's a great time to put them in the Twitch chat. I'll keep an eye on those, and we can answer those as we go along. Okay, so what Nathan suggests here, and I think this is a great shout. So if you've not got Neo4j sandbox, Neo4j desktop set up, then this could be a really quick way to do it. So we're going to be using the graph data science library. So for those of you who are following along, I'm going to give you a couple of moments. You can launch a Neo4j sandbox. So if you go to sandbox.neo4j.com, and then what you can do is you can go to this address. Actually, let me go to the other one. So if we go to neo4j.com/sandbox. Let's do this one. So if you go to neo4j.com/sandbox, then what you can do is if you click here to launch the free sandbox, then all you need to do is sign in. So you can use your social media credentials. So if you're using Google or Facebook, you can use those to log in, or you can log in with email as well. And then you can select the sandbox. Let's just do that quickly. So what you can do is if you want to sign up, so let's just do that as an example. So you can either sign up with that, or I can sign up with this. If I do neo4j.com and pick a password, and I put in my details, Lju Lazarevic. You can sign up, and then you can get, oh my goodness, all right, I'm already in there. But anyway, so I'll have to look at my password. But if you effectively sign in, then what you can do is you can select you can select a project, and what we're going to do is select the graph data science project there. So we're not going to be using the data that's in there. We're using it because it's got the graph data science plugin. So if I just quickly explain what's going on there. So the graph data science library is a library of graph algorithms that we've got in there. So some of you may have come across the graph algorithms library before. So that's the precursor to graph data science library. So graph data science is the successor of the graph algorithms library. And in there we've got loads of algorithms. So if I just quickly go over to docs, you can see here many of the algorithms that we've got here. So you can have a sense of all of those in the documentation. And we're going to be using some of those for the example in this blog post. If you've not come across graph algorithms before, basically they're a category of algorithms that help us better understand graph structures that we have. And you've got different types of groupings of graph algorithms. So for example, you have community detection, and that's all about trying to understand how nodes may be grouped to each other based on relationships and their connections. So famous ones are, for example, Louvain community detection. You'll have things such as centrality detection. So this is all about trying to find important nodes in your network, and that again is going to be based on how they're connected. So a famous one would be Pagerank. So that's the sorting algorithm that was invented by Google, by Larry Page, that tries to tell you which are the important pages based on how they're connected by other pages. And you'll have a similarity algorithm and so forth. So you've got a number of different graph algorithms, and what they're trying to do is they're trying to help you understand certain features or structures of your graph. So we're going to do that. So if you're following along with desktop, then what you can do, so I've got Neo4j desktop here, I've added my database. So what I'm going to do is add a plugin, which is going to be the Graph Data Science library. Now, I believe I'm not going to do it. Actually, we'll install. Let's see what happens. I suspect this is going to install the version for 4.0. So I'm going to just have a quick check, and if it does, then I'll show you how to manually install that. So we're going to be using the Graph Data Science library. So again, if you're doing it with Sandbox, that's probably the easiest way to do it. So neo4j.com/sandbox, and you've got the link as well in the stream. This stream chat, and then just select the Graph Data Science library. So I'm just going to quickly have a look what version of the plugin I've got here. And right, I believe, let me just double check. Let's have a quick look at the documentation. So if you need to download any of the plugins, so for example, if you need to download the Graph Data Science library, or we've got the ETL tool and so forth, then you can go to neo4j.com/downloads, and you'll see the option about integrators and connectors, so you can click on that to see. Okay, no, we're good. So 1.1 is compatible with our version of Neo4j, so we can carry on. So this is how I've added it. I'm just going to start my database now. So either follow along with Neo4j desktop or with Sandbox. And let's get back to the article. So, what we're going to be doing is looking at how influence diffuses from neighbour to neighbour. So I'll be going through these queries as well for the first time. So I've read the article, but I've not executed the queries. So we're going to be doing this together now. And we're going to be looking at sort of interactions. So let's have a quick look what we've got here. Oh, okay, so we're going to be looking at Game of Thrones interactions. Okay, so I believe we are going to be reusing this data, so that's fine. So this is also a good opportunity as well to talk through how to use the Graph Data Science library. And what happens when you use it? What you need to do, there's kind of two steps. So you don't sort of immediately go, right, I'm going to run a graph algorithm on my data. You have this two-step approach. So the first step, what you do is you think about what you're trying to, what data are you trying to query, and what is that structure of the data. So what we do as the first pass is create a graph projection. And this is a great opportunity to think about how our data is going to be connected. So let's have a look first at our Game of Thrones data. So actually, I think, do I have the Game of Thrones data here? I think I may well end up having to get the Game of Thrones data. So one moment, I will join you all on Sandbox. So when you sign into Sandbox, you have something looking like this. So I'm going to click on New Project. I'm going to click Graph Data Science, and I'm going to launch this project. And I shall stop this because I'm not going to use this. I forgot we're going to need the Game of Thrones data. Okay. So just wait for that to set up. Pretty quick. And there we go. And we're going to open this with browser. So let's have a quick look at what our data set looks like. Okay, so we're going to click over here and have a look at what we've got. Okay, so we've got a bunch of nodes and different interactions. So this data set here has the interactions of different characters, and this is being pulled from the various books. So I've forgotten the name of, actually, you should say here. Yes, okay, so I don't know if we say the source of who put this. Oh yes, here we go. So so this is the various bits of work that have gone on to effectively go through the various books. I think it's the various sagas of, was it a Song of Fire and Ice, or I can't remember the exact title, but what we know is Game of Thrones, and they've gone through each of the books and pulled out each of the characters and then talked about how they interact with each other, and it's quite an interesting data set. So let's have a quick look at the data model. So I'm going to do call db.schema. Okay, so let's talk about what's going on here. So just extract these out a little bit. And I'll talk about this bloom, the bloom node that's just run off. I will explain that one in a second for those of you who are curious as to what that is about. Okay, so we've got our various data, and then what you can see going on here is we've got the books. Okay, so this book will talk about, so this will be where we've got our information from. Let me make this a bit bigger. We have got king. Okay, so I assume we've got different kings. I'm going to have to admit, I've only read the first book, and that was a few years ago. That's all good. It's got a king. King has status. So we've got dead, so that's presumably going to attach to when people have died. We have got, if you notice all of the interaction labels we've got here, so these I believe refer to the different books. So interacts 1, so they'll have interacted in the first book, interacts 2 will be the second book, and so forth. So we've got the different interactions, we've got the different roles that some of these characters have played. We've got what house they're associated with, as well as, okay, so they may belong to a house, or they may have been the house that are attacking in a battle, or they may have been a house that were defending in a battle. And we've got regions and locations, so got an interesting set of things going on. And what you can see here is that, and we'll run a query to examine what's going on here. But what's going on here is we've got double labeling. So we've got person. So here we might have person who's also a king, or a person who's also a knight. So this is where you see this. If I drag person out here, you can see all of these interactions. So you can see already the structure of our graph. We've got a lot of interactions, like person-to-person interactions going on. So when we think about, if we're looking at influence, what we're interested in is how different people are interacting, you know, how are they connected to other people. And we started talking about creating a projection, graph projection. So just to give you an example, so here we've pretty much got all the interactions in place, so that's great, that's what we're interested in. But if we had an example like person has a relationship with the product, so let's say a person buys trainers and another person buys trainers, and we wanted to understand the interactions of the people in this case, and we're using our sort of our our proxy point as being the product that they buy. So if we wanted to understand if there's sort of influence via a product, so what we'd need to do is we'd need to create a projection where we'd say, well, actually, even though my physical graph has got 2 person nodes and there's a product in the middle, what I want to do is I want to write a query which creates like a virtual connection between those 2 people, and then we forget about the product trainers. So that's what the graph projection allows us to do. It allows us to take a step back and think about, okay, my graph looks like a certain way, and what I need to do is take a step back and think about what would my graph need to look like to be able to answer the question that I'm looking to do. So something like when we're looking at communities in a graph, those tend to be what we call monopartite graph, and what that basically says is that we're not looking at 2 different sort of node groups. We're actually looking at just the one node and how it interacts, how that node of that same category interacts with with others of the node in the same category, if that makes sense. So we can talk that a bit more. If that doesn't make sense, then just let me know on the chat and I can go through more detail. We can give some examples at the end. But anyway, so I digress. So we've had a look, so we can kind of see what's going on. So we already have this person interacting with person, and then what we can do, just so we can give you an example of what's going on, if we have a look at what labels are in use, so match n, and let's do return labels n, count n as C, order by C descending. So let's see what's going on. Oops. So you can see, so this is what we're talking about. So as you can see, we've got person, so person's kind of like our main thing, and then for certain situations we've got an additional label, and you can do that with Neo4j. You can have more than one label associated with a node. So you can see here we've been tagging persons that are dead, we've been tagging persons that are knights, we've been tagging persons that are knights that are also dead, persons that are king, dead persons that are dead kings, and so forth. So you can see what's going on there. So you can see we're using multi-label. So although our data model kind of looks like this, it's not capturing the fact that we've got multiple labels on our nodes. So that's why it kind of looks like this. But if we, for example, not going to do it today, but if I removed all of the dead and knight labels and things like that, then you'd notice that this claps down a lot and simplifies. Oh, I forgot to mention the Bloom perspective. So the reason why you'll see a Bloom perspective node, it's just that the Bloom data is stored to local database. So I suspect we're going to touch on Bloom during this session. So that just stores all of the information about the Bloom perspective. So like what node colors have we used, what labels are we using, did we create any search phrases and all that stuff. So that's just why it's there. So don't worry about that. So you can see that's what's going on. So we've had a quick look at our data and we know what's happening. So when I go back to the article, we're creating the graph projection. So what we're going to do here is, because our data already has those connections between persons and the interactions, we don't need to shape our projection. But what you can do is, so this is going to pull it straight from the store. So this immediately pulls up all of the person, anything that's got a person node, and the interactions. So this is pulling the relationship type of interacts. If we wanted to, sort of coming back to our example where we have person buys product and another person buys the same product, and we wanted to understand the influence between those person nodes, what we would do in that situation is we can use Cypher to create our graph projection, and then what we'd probably do is we'd have a Cypher statement to say, so like, match p person return ID p. So that returns all of the node IDs for person nodes because that's what we want. And then we'd provide a second Cypher query to say what the relationships between those two nodes should look like. So we'd probably do something like match P1 person buys product buys P2 person, and then we would return the node IDs for the first person and the second person, so P1 and P2. And then what that basically tells the projection loader is that actually I want you to pretend that there is a direct relationship between those two person nodes and forget that product node in the middle. So you have a huge amount of flexibility to be able to shape and craft your graph based on what graph algorithms you want to run, based on how you think the data should be structured when you run that algorithm. So what's going on here is because we already have those interactions, so we saw that if we look here. So if we go to the person node, so you can see we've already got that interacts relationship already with person to person, so we don't need to do anything, we just pull that data straight up. So so we're going to do that, and this is loading. So let's talk a little bit more about what's going on here in the projection that we're loading. You can see as well that we've got our relationship, so interacts, that's the relationship we're going to bring, and we've also got this orientation. So what you can do as well is you can specify what direction you want how you want the relationship to be treated. So you can either have it sort of, and let's have a quick look at the documentation so it makes more sense. Look at the projections. So creating graphs in a catalogue. So this is what we call the native projection, and it's called the native projection because we're not having to shape the data in any way, we're just pulling it as is, so it's native to how we've loaded it in the database. And the cipher projection is where we're using cipher queries to reshape how we want our projection to look like. But if we have a look here, so you can see we'll have an example here. We talk about relationship directions. There you go. So you can pick the orientation. So natural is basically saying we want to keep the relationship direction that we already have. So for example, if we had Bob interacts with, and we've got an outbound relationship from Bob to Jane as an example, then natural would keep that. Reverse would be we flip it the other side. So we say, well, actually we want it to look like it's an outbound relationship going from Jane. And undirected says we're not interested in relationship direction. Now the reason why you may use, or why relationship direction may be important when you're using the algorithm, is there'll be certain ones where you need to provide a direction, or there'll be certain scenarios that you'll be investigating where the direction is relevant. So let me just think of an example. So for example, if you're just thinking of a random example here, so if we were looking at, say, healthcare providers with patients, and let's say we wanted to see like which healthcare providers were more influential, so maybe they had sort of more referrals or something like that, then it's going to be the healthcare provider that's going to be pertinent with direction of influence. So even though the healthcare provider and the patient are both going to be people nodes in this example, or potentially, actually what we're interested in is like healthcare provider provides care to patient. We would want to keep that direction because that would be important in our analysis. So you'll have many examples like this as well. But in this example here, because what we're interested in is influence, and specifically the set that we're looking at, for this example, and I believe because we're going to be looking at weakly connected components, it's not, yeah, here we go. So we're not interested so much in the direction of the connection. What we're interested in is that they're connected. So what this does here, this is going to go off and create a projection. So I'm going to copy and paste this into the browser. And you can see it's created our projection. And what you can do if you want to see what graph projections you've got, you do call gds.graph.list. And what this will do is this will list all of the graph projections you've currently got. So you can see here we've just got this one, the Game of Thrones interaction. Okay, so let's have a look. So what we're going to do, we're going to find the weakly connected components. We're going to write a property called interacts, back to the graph. Okay, so we are going to be calling weakly connected components, and we're going to be doing write property. So again, let's go over to documentation and have a look at weakly connected components. So you can see here, we're running on undirected graph, and effectively how I understand weakly connected components to work. What we're trying to do is we're trying to predict any sort of groupings together, sort of based on how they're connected, and this is useful to find any sort of outlier data that we want to ignore and not look at as well. So okay, so we'll have a quick look. So we said that we're going to be creating a write property. So what you can do, and let's quick talk about the graph algorithms. So you have sort of 3 modes pretty much with what you can do. So you can either write, and this is when you can write back to properties on the, I think it's either the nodes or the relationships that you can write back. You can stream, so what you can do is you don't make any writes, but you can stream the data out. And you can mutate your graph as well. So what you can do is, if you go, well, I don't want to make any changes to my database, but what I do want to do is I want to take the output of the results that I've got from the first graph algorithm that I've run, and I want to put those changes into my projected graph, my graph projection. So you can do that, and then you can continue working on that projected graph. So we're not going to do that. We're going to follow Nathan's instructions, and we're going to be doing the write. So let's have a quick look at the write option here. So in this example, we will write to the property. So we're going to be creating a property on our nodes, and we're going to be writing some values to the property. So it'll be the sort of community ID that we're going to put in there. And I forgot to mention, so weakly connected components is a community detection algorithm. Okay, so that's what's going on. So we've got the instruction there. Let's do this. So let's go into here, and you can see here. So this is our graph projection that we created earlier. We're going to run weakly connected components, and then what we're going to do, we're going to create this property called interacts WCC partition, and that's going to be created on those person nodes that we've brought in, and then that's going to put the community identifier that it's being grouped with. So let's run that. This will be fast. There we go. Less than half a second. And let's have a look at what we've created. So if we do p person, and let's return some to begin with. So return p dot. Do we use name for do we have name on here? Oh, we do have a name. Let hopefully name its name. Otherwise, that's fine. And let's do p dot, and we've got that new property now, which is interacts WCC partition. And let's just bring back the first 5 to begin with. Let's see what comes back. Oh, okay. Right, so you can straight away see the first 4 that we grabbed are all part of the same community. So let's just quickly chuck together a query where we're going to group them together. So how will I do this? Let's just reuse this. So return as partition ID ordered by PID. Okay, this hopefully should get us. Oh, there we go. Right, so you can see we've got in our first community we've got all of these names, and then we've got a group, a lot of people in their own community. Okay, that's interesting. Oh, that's very interesting. Okay, so let's see what happens next. Add an interactor label to the people in the largest connected component. Well, we know which one that is. That's 0. We just saw that. So we should now have 795 people with an activist label. I mean, to be honest with you, that community 0 looks pretty huge. I suspect that probably is the 795. Okay, brilliant. Right, so let's do this. So let's have a look at what we're going to do here in this query. Okay, we're matching p-person. So we're matching the partition. So we're creating an alias to the partition. We're collecting all of the person nodes and we're calling that collection people. We're doing a count of all of the p nodes. We've got person count and we're ordering by person count descending. So that's a bit similar to what we just did. So what we're doing is we are creating a collection of the person nodes and we're doing a count of that, and then we're going to basically return them by the largest number first. So that's going to be collection 0 that we just saw. And we limit 1, so we only want to take the first result, so we want the biggest collection. And then we're unwinding because that was a collection, so we need to unwind it before we can do something with the nodes. And then we're setting the interactor label onto those person nodes, and then we're going to return the count. Okay. So let's do that. There we go, 375, and I'm sure if I did a count on this, we'd get the same value back as well. Okay. What's next? Let's set parameter designating the pair for matching neighbours with A or B. Okay, I think we're going to be randomly setting labels, so let's do that. So this is effectively creating some parameters that we can use in our queries later. And going to set everybody, so we're setting more labels here, so we're setting B labels, and well, we shouldn't have any A labels because we've not set any, but we're going to set everybody a B label. So let's do that as well. Okay. And what we're going to do next is we are going to pick some people that we're going to set an A label to. So we're picking Drogo and Doria. And what we're going to do here is we're going to move those B labels. So we set everybody in that. Do you remember that first community? So we gave them all of them an interactor label. So we're picking everybody in that big community that we found. And now what we're going to do is we're going to pick 2 of those. Although I think there's a few Drogos and a few Dorias. So we can have a look at that in a second. And we're going to remove that B label that we set. I'm going to give them an A label. And actually return P. So we're going to see which ones we've set there. So let's go back to that. Oh, it's 2 labels. Okay, cool. So we've just got those 2 characters there. Excellent. Now, what we're going to do next. Okay, so we set a couple of parameters. So A reward is 2, B reward is 1. So let's copy and paste this query, and let's talk through what's going on in this query. So what we're going to be doing is we're trying to find all of the B characters that have an interaction with A. So remember we've got it was Drogo and Daria that were on there. So we're going to find all of the characters that are connected to them, and then we're going to find out who those characters interact with. So here is, like, for example, Drogo. Then we're going to find all of the people that interact with Drogo, and then all those people we're then going to find their co-interactors. I'm going to get the distinct though. So just think, so we're effectively going 2 hops, or up 2 hops from Drogo. We're going to get the distinct, so that basically, because we may be referring to the same node several times, because there could be more than one path, as we are now doing up to 2 hops away. And we're going to, what we're going to do, case when A in labels N, then A reward. Oh, okay, and then what we're going to do is we're going to check to see, because bearing in mind that P, some of those P's are going to go back to the ones that we tagged with an A label, because you think about it, because we've split that query, so you think about it, let's say we go, I'm going to show my complete lack of knowledge of Game of Thrones, but you think about P, so let's say P is Drogo, so we've got Drogo, so Drogo goes out to say Bob, and then we're collecting Bob, and then when we go back again, Bob is going to interact with Drogo. So that's what's happening in the second part of the query. So what we're saying here is if the character if the character has the label A, so labels N just basically says all of the labels associated with that node, then we're going to set it with A reward, and A reward was 2. Oh, excuse me. And then we're saying, well, if you've got a B label, so remember we've either got B's or A's, nobody's got both labels, then we're going to set the B reward, which was 1. So that's what so effectively saying what value we're going to set. So this is this value, and we're saying the sum where A reward is less than B reward. So we'll the summing that. So what we're saying here is where this condition is true, we're going to remove the B label and set the A label. So now remember that the vast majority, barring 2 characters, had the B label set to them, and it was just the 2 characters where we had the A label set to them. So effectively, what's happening here is where this condition is met, we're going to switch them over to the A label, and then we're going to return them. So let's run this and see who have we converted. Okay, so we've got 3 characters, and again, if we double click, let's have a quick look at what's going on here. So let's double click Doria, and let's double click Drogo. There we go. So we've got here Iriago. So I suspect let's have a look what's going on. And we've got okay, so we got here as well. And do we have? We don't have. And we've got Jomo. So you can see they're all connected to Drogo while that's happened. And what's probably happened while they've switched over is there'll be sort of more than one path to get between the two, which I suspect is what is going on. Okay, so those 3 have been switched over. Let's see what happens next. Okay, so rerun the query multiple times and you can see that A strategy is fusing across the network. After a few iterations, no new enables are switching to A. Okay, let's do that. Let's see what happens. So what you can do as well, I'm going to pin this query, and you can pin, so this frame, I say query, it's the frame. So what you can do is if you press this pin, it just makes sure that that frame stays at the top. Now the reason why I'm doing this is that we're going to rerun this query a few times. So again, if we quickly have a look and remind ourselves what happens is as this, so because now we've got oops, let's make it a bit bigger, because now we've got 5 people that have got an A label associated with them. So obviously you can start to see that the influence is now going to spread, and what's going to happen is that you're going to see this sort of exponential spread across the network. So you know, as this condition is met, then we switch the B labels over to the A labels. So I'm going to rerun this query several times by pressing this very handy button here, and what this does, it's refresh, but effectively what it does is it will rerun the query here. So when I run this, actually, do we want to show? I'm just trying to think. Do we also want to show the ones who seeded? We'll leave it for now. So if I rerun this, okay, we had another one. So Virgo's been added. Let's run it again. nobody got added. Okay, that's it. No more. Okay, so let's have a look what's going on. So let's bring back all of the characters who've got a B label. So I'm just going to quickly rewrite this. I'm going to borrow this query. And let's say we want interacts with B. So let's see what's going on. I'm going to return everything. So we're not going to have a huge... Oh, no, I didn't want B. I wanted A, didn't I? That's all right. Let's stop this query. Oh dear. That's all right. So, oops. Let's just get rid of this. Let's go back to the previous query. I want a... There we go. So you can see, so these are all of the A characters. Now you can see we've run it and it's not going any further. So obviously not a particularly influential network, but that's okay. Right, let's have a look. Yep, unfortunately no new neighbours are switching to A. Oh, okay. So that's been done in Bloom. We're doing it in browser, so you can see it's not gotten very far. So these are our 6 A's. So yep, so this is an example of where our innovation has stalled. So you saw we kept running it. In fact, we can oh, it's unpinned my query. But you can see we ran that query several times and it just wasn't spreading any further. So let's see what's going on next. So, aha! So what we're going to do now is we're going to be changing the parameters. So remember we had the rewards where it was A reward was 2 and B reward was 1. We're going to be making A reward much bigger. So we can start, already you can start to see what's going to happen when it runs that condition to do a sum of the interactions. So let's do that and let's rerun that. Oh, another option would be to... I fancy rerunning the same query because I think it's fun to see how the spread grows out, and maybe if we get the chance we can see if we can try and improve the visuals a little bit so we can see like who seeded and then who went out. So that might be a fun one to do. So let's go back to our original query. This was that one. So bearing in mind now, so whereas before this was 2 and 1, now A reward is much more heavily seeded. So this is where we should start to see it really just grow out. So let's do this. And we're going to pin this. So immediately, so do you remember we ran that previous query several times and it was not, it wouldn't do any more. Now we've got 6 here, and I suspect what we're going to see it really jump and shoot across the network. So there we go. Oh wow, you can see it, you can really start to see the node spreading out. So if I bring back this one here, so this query here, this is showing us A interacting with A. So do you remember we were stuck on 6, and now we're going to start seeing that this is growing. There we go. And you can see how it's now, you can see, let me just expand that, so you can see how it's growing and the mass interactions between them, and that's spreading out. So let's run it one more, because the fun thing with this is going to get bigger and bigger and bigger, because obviously you sort of think about how you've got all of your you've got all of the people tagged with A, and because that's growing, then there's going to be so it's going to get to a point where it just very quickly sort of rushes across the graph. So let's look at that. See, And I included the spotted cats. There you go. So you can see that with the number of the nodes is increasing, and at some point we're going to get to the stage where as long as the nodes are connected in some way, then eventually, presumably with this weighting, it's going to spread across the entire graph, and everyone's going to be switched over to A. Okay, so we've got an example here of where we can use periodic commit. That's going to effectively run this, and what this is going to do, so whereas before I just kept pressing that refresh button, what this is going to do is we just say how many times we want it to, in this case it's going to keep going until everything's been, until it returns a 0. So yeah, so this keeps going until it can't switch anymore. So I'm going to leave that for now. We did a similar thing. I think it's more fun to just step through and see what's going on, which is what we've done. And there we go. Okay, that's cool. That was really interesting. So I get to read some fantastic articles. We've got such an amazing amount of content we get from the community. And it's really great to actually take some time to step back and just let's step through and let's work with the examples that people have done. So this has been a really educational post for me to go through that Nathan's put together, and it was really fascinating to see how we saw that spread across the network about picking that right reward factor to try and persuade and influence your network to switch to a different position, so you can really start to get a flavour of how influence can drive the adoption of innovation. And you can see like the reward can be lots of different things. So the reward can be like sort of recognised social standing. It could be what that innovation delivers. So like it significantly improves your quality of life and that kind of thing. So it's really fascinating to see how the reward in this example here can drive the propagation of some innovation or some thoughts or that kind of thing. So it's great fun. So I don't know if you guys have got any questions. I'll keep a quick eye in the chat. If you want to have a look at this blog post, so what you can do, you can go to the, if you want to see some of the Medium posts, we've got, and Nathan's done a lot of posts, really interesting ones. So he's done one on Sudoku as well, which I saw the other day. And you want to have a look at the other things that community are doing. If you go to medium.com/@Neo4j, and then here you can see our, here you can see all the various stories that have been posted. And if you go to our, you can go to our developer blog post. So if you go /Neo4j, you can see all of the posts up there as well. So that's really cool. That was great fun. I don't know how you all found it. Let me know. Do you find it useful for us to go through some of the featured articles in Twin4j? This week in Neo4j. Let me know. I mean, we can keep doing this. I mean, I found this really interesting. Other than that, if there's any other things you'd like me to explore graph-wise, let me know. So you can either do that by you can either ping me on LZL. Maybe we should set something up as well on the community page, so if you've got any ideas to post through. But that was that. So if we don't have any questions, then I will call it a day. And again, so I'm not going to be doing anything next Monday, so that's the 22nd of June. I'm not going to be doing a stream. However, 29th of June, we are going to be doing something special, so please do come and join us then. And from that, I hope you had fun. Do have a go with Nathan's post, explore it for yourself, go through those codes, see how you can propagate across the network, and hope you have a fabulous day, and see you soon.